Today I am going to discuss about least square technique for linear fitting. Here is the problem statement. A first order reaction follows the rate equation, that is ln C by C0 is equal to minus kT. Now here experimental data are given, the different time instant, that concentration is already given here. So from that, by using least square technique, we have to find out the rate constant K. Now first we must need to know the mathematical foundation. So that straight line equation is y is equal to ax plus b. So that is the linear model where x is the independent variable and y is dependent variable. A is the slope of the line and b is the y intercept. I mean b is the actually intercept. Now we have the data. So here actual data. So that is different time instant. We have that c. Okay, so if we consider time is a x and c is y, so we have that yi, and then if I fit and if I get that that y is equal to x and b, so that is actually nothing but predicted. So now here we are doing we are calculating error between model and actual data. So s of a and b, because right now we don't know what is a and b. Based on that a and b, so we can fit the model. So summation of means we are calculating error, and we are taking that error square and we are adding all this error. So that is I is equal to 1 to n yi minus axi plus b and whole square. So now our target is, so whatever error we are getting, so we have to minimize that error. So for that, what we are going to do is that we are taking the partial derivative with respect to that a and b, that is the parameter. So now if I do that dsa by dA, so we'll get minus 2 summation of I is equal to 1 to n yi minus axi plus b into xi. Similarly, if I do a partial differentiation with respect to b, so we'll get minus 2 summation of I to n yi minus axi plus b is equal to 0. Now here I got two equation. Now if I solve, then we'll get the unknown a and b. So now here we are getting two equation. So if I expand this and this, we'll get these two equation. So from these two equation, if I write in the if I reorganize, so we'll get that a of summation of 1 to n xi square plus b summation of I to n xi is equal to summation of I 1 to n xi yi. Similarly, so a summation of I is equal to 1 to n xi plus nb equal to summation of I to n yi. Now if I write this equation in matrix form, so that will be summation of xi square, summation of xi and n, and then ab are the unknown, and this is the known coefficient, okay, constant coefficient. So from that, if I get all this value and if I write in matrix form and then if I solve, then we'll get easily a and b. Now here even if I solve that a and b using Cramer's rule, we'll get a is equal to this formula, b is equal to this formula, or otherwise you got the matrix and then we can solve that. Now here that problem, this is the problem statement. Okay, so now we are going to fit that ln C by C0 is equal to minus kT. So we are writing that y is equal to ax plus b. So now here y is nothing but ln C by C0, and ax is that a is minus k and x is actually t, and b is the intercept, that is 0. Okay, so now here, so we have t datas and means x datas and ln C by C0 datas, so that is y datas. So we have to take the summation of that x, summation of y, then summation of x square, summation of x into y. So if I do that calculation, we'll get all this data, and then we have that n is equal to, so n is number of data, so that is n is equal to 5, summation of t is equal to 100, summation of ln C by C0, so that we got here. Okay, then summation of t square, so we got 3000, summation of t means t ln C by C0, that also we got. Now if I put in the matrix, so we'll get that matrix equation 3000. So if I go here, so that is our equation. Okay, so summation of x square, summation of xi, summation of xin. So if I plug all this, so we'll get the matrix format here. So 3000, 100, 105 AB, then minus 61.700 minus 2.060. Now if I use that formula and we put all this value, so from that we can easily calculate that a is nothing but the slope. So slope is here minus 0.0205, and b, again if I use that equation, plug these all values, and if I do the calculation, we'll get b is nothing but minus 0.002. So after getting that, so we can easily predict the value. So before that, we are going to calculate coefficient of determination. So that is r square value. If r square is very close to 1, so that will be that fitting is good. So r square is 1 minus ss res and ss total. So that res is sum of square of residual, total sum of square. So that is nothing but 1 minus summation of y minus yi cap whole square. So here yi cap is predicted value and yi is means observed value. Okay, by summation of yi minus yi cap whole square. So how we will calculate all this? So in this table we can calculate. So t is equal to y observed and y predict we will get from that equation, that y is equal to x plus b, and then we can calculate y minus y cap square, y then y minus y mean square we can calculate, and from that we can easily calculate r square. So that is 0.999. so that is nearly equivalent to 1. So our that fitting is very nice. Anyway, so after doing that, so fitted equation is ln c by c0, that is y is equal to minus that kt, so minus here minus ax plus b. So here minus kt means minus 0.0205 t minus b is actually 0, so it is close to 0. So from that we can easily calculate what will be the rate constant. Rate constant is, so that is 0.0205 plus minus 0.003 minutes, that inverse. So actually this is the minus 0.00205, so 0.0205 actually the rate constant, and coefficient of determination is r square is equal to 0.999. so that's it. That is the way we can calculate that rate constant k by using least square technique. That's it.